Okay. Thank you, Shankar, for the introduction. So, good afternoon, everyone. I believe you have been hearing a lot about modernization throughout this conference. So, I'm straight away going to discuss how we can use integration for modernization. So, to do that, I'm going to use a story. So, this story is about a hypothetical logistic company called Global Logi, so which is struggling with some outdated systems. So this Global Logi has been there for some time. So they have some bunch of legacy systems. So think about a setup where you have a system for doing inventory and another separate system for doing shipment tracking and another system for doing order management. So these systems are isolated systems that doesn't talk to each other. So sometimes it's been a headache for even for their employees to get something done because these are not interconnected. They are working as an isolated thing. But what if we want to bring some new capability, like introducing a mobile tracking system or bringing some more IoT related stuff? Is pretty complicated. But so even though they have a whole lot of problems with this legacy system, they really works. So that's why they exist for years without getting replaced. So, but to be competitive in the market, to win the competition, they decided to introduce some new functionality into this particular system. So specifically, they wanted to bring mobile tracking application, so where their customers can track the shipment using mobiles, and also they wanted to get a web-based system that is offer their customers to place shipment through web. So with having these legacy systems, how can they get this done? So before finding out that, let me quickly explain some of the challenges that they are facing with current system at the moment. So these legacy systems has outdated architectures. So that means it's really hard to get integrated with the modern technology. So if you try to do something, that might end up with downtime. And secondly, the most critical thing is security vulnerabilities. So since that these systems are very old, they might have a whole lot of libraries that unpatched libraries for recent security vulnerabilities. So trying to interfere with these systems might end up with a security breach. And the third one is the high maintenance cost. So these systems eat up into a big portion of their IT budget. So the last point is the difficulty in scaling. So obviously these systems have been scaled for some extent, but beyond that point it's pretty hard to scale. So having all these troubles, why can't we simply replace the entire system? So these systems have a bunch of critical data and processes. So, and these systems has been there for a while. That means they are proven for their reliability. So someone can't simply sub this with a new system all of a sudden, right? So doing that might cause downtimes when even nobody wants to take that risk. And these systems might have crazy dependencies on other things as well. So if you try to do some change, that might affect somewhere else. So replacing that is not that simple. And also when something breaks, there might not be enough expertise available in the organization to fix them. Since these systems are built very long time ago, the people who worked on these systems might have left the company or might have retired. So the people problem also there. So people will like to run these systems without doing any modifications. And also there are some resistance. So there can be people who are already familiar with the system who doesn't like to see a change. So that resistance also there. So that's why we can't simply get rid of the legacy system. So even though we can't get rid of that, still we need to offer these new capabilities. So how can we do that? So that's the place where we get integrations help. So let's see how we do that. So let me now explain the role of integration in modernization. Integration is the bridge that connects legacy systems to modern technology. So the integration allows both new and the old systems to work together. So as we know, the legacy systems brings the stability, and the new system brings innovation. What bringing these together is what integration does to do the modernization in a seamless manner. So there are some advantages of using integration for modernization. So the first one is the minimizing the disruption. So basically, when you are bringing new features into this system, so you are doing in a step-by-step manner. So you can keep the existing legacy system running and get new features step by step. So you don't have a downtime in introducing new features. And since that this existing legacy system is keep on running without a complete replacement, the investment that you have to make to get new features is less, because you are only investing on getting new features. The existing system will keep on running. And then the flexibility. So if you are replacing the entire system at once, you have to do everything at once and do the cutover to the new system. But in this case, you can run the existing system without doing any, leave it running, and bring the new features in the phase that you like to. So basically, you can take a step-by-step approach to bringing different capabilities into the system. And also, as we know, these organizations has invested a lot into these existing systems. So if you are just throwing it away, then you will lose the investment that you have made into those systems. So when you are investing on integration, what will happen is you are investing only on that particular features that you are bringing into the new system. And then again, the scalability aspect. The scalability also, even though this legacy system is not scalable anymore, while doing this new system using this integration, that can be scaled without a problem. So these are the advantages we see in this approach. So I have come up with some framework for do this modernization using the integration approach. So here we have 5 different steps that we are going to take. So the first step is assess the current system and the needs. So here what we do is we need to thoroughly understand what's the state of the current system. So basically we need to have a proper understanding of what these systems does and how they interact with each other. So that kind of understanding we need to have. And so this is one of the challenging tasks we have in a modernization project. In my experience, from the time that we are allocating for a modernization project, sometimes we might have to spend half of the time on analyzing the current system. Because you might say we can use the documentation available in the system, but by practice, there are some consequences there as well, because in the beginning of the project, you might be following all the best practices and doing the documentation, but later on, when time goes on, people forgot to follow the best practices. They might have forgot to document stuff, the changes they have made. So that leads to out of sync of the documentation and whatever the things that you have in the production. So that it's not that simple. And then the next resource we have is people. So if we have people who knows about the existing system, that's an advantage. But and if you have people who understand the end-to-end story and end-to-end the way the system works, that's added advantage. But practically, I think that's not the case in most cases, because in most of the time, people who build these systems and people who know how to operate these systems has been left from the company, or maybe they have retired. So practically speaking, this is not a luxury that everybody will get in a modernization project. And recently, I have seen some companies have developed tools based on AI that analyzes the whatever existing documentation and the code and maybe whatever the information we have in an existing system, and that gives out a comprehensive report on the state of the current system. So I personally haven't tried out those, but if that works, that will cut down the time that we are spending on modernization project to a great extent. Okay, so let's move on to the second step. So it's about defining integration strategy and choosing technologies. So under that, I have 4 different things to do. So the first one is selecting the architectural style. So there are 2 main architectural styles that we can see today. So first one is ESB, or the centralized architecture. So in centralized architecture, what happens is that every system is getting connected to the central hub, which we call as enterprise service bus. And all the integration are developed and deployed into this central hub. So even though this has been introduced 2 decades back, we can still see that there are people and organizations still uses this architectural style. And the next one is the microservices architecture. In microservices architecture, as you can see, there's no central hub, but still the integration problem is there. The integration problem is dispersed into multiple nodes or multiple services. So in this particular scenario for this modernization project, I will go with microservices architecture. Okay, so the next thing is integration types. So we have several integration types. So the first one is the integration as APIs. So here what happens is that the legacy system is wrapped and exposed as an API to the consumers. So in most cases today we are using RESTful APIs to do this, but integration as APIs are not limited to REST APIs. There are other protocols like GraphQL, gRPC, and WebSockets. And then next type is automations. Automations in integration means triggering a particular integration flow in a periodic manner or in a given interval. So basically, you would find these type of integration typically in batch processors and systems where we sync data between 2 different systems. So basically, a periodic task that happen sometime, some batch job happen in some particular time in the day. So that type of integrations are there. And the next type is event-based integrations. In integration as APIs, we were mainly talking about the request response pattern. But here, it's only a single direction. So basically, integration is triggered by a particular event. So in this case, mostly we were talking about, in these days, we are talking about Kafka technology. So basically, Kafka is being used in most of the places on event integration. And not only Kafka, there are certain protocols such as MQT is being used on IoT world. And there are conventional protocols such as JMS and AMQP. And the next type is file integration. In file integration, an integration is triggered by availability in a file. So basically, availability in a file can be either in a local file system, or it can be either in a remote file system such as over an FTP. So integration get triggered only if you have something available as a file. And the next is on, so this is something very new. So AI agents. So for the sake of the completeness, I have included it here, but I'm not going to talk about this at this moment because Shafrin is going to discuss about this in the next session in detail. So for this particular project, I'm going to select integration as APIs, and I might also need file-based integration because we are dealing with some legacy systems here. So next we need to choose the development styles. So in development styles, we can see two main development styles. So the first one is low-code development style. So basically in low-code, what you do is you have integration development environment that has a graphical editor where you can drag and drop and wire components together to build some integration. Here you will write, you might not need to write code, but for the greatest extent, but when you try to do some more complex things, you might have to switch to code as well. But generally 90% of the time you can stay in the low code experience and get the integration configurations done. And the next one is pro code. So the pro code is about developing your entire integration using code. It can be either in a general purpose language like Java, or maybe we can do it using some a language that is designed specifically for doing integration, such as Ballerina. So for this particular project, I am going to use the low-code approach. And moving on, and most of the low-code platforms offer AI assistance now. So basically using the AI assistance, we can describe the integration problem using natural language, and that is capable of generating your integration configurations. So that will cut down the time you are spending on learning these products immensely. So that again will be covered by Shafrin in the next session. Okay, so now that we selected the low-code approach as the development style, and then we have the deployment options. So under that we have several deployment options. So you can decide to deploy all your integration on your data center, that is the on-premise deployment, or else you can deploy your integration on the public cloud or in the iPaaS. So when you do that, you don't need to worry about the underlying infrastructure. You don't need to worry about installing integration tools into this infrastructure. Everything is taken care of by the iPaaS. Or else you can use private cloud. Basically, private cloud is again you are installing integration tools into some cloud offering, and on top of that, you are deploying your integration configuration. But in most cases, when we are doing this legacy modernization, what we find is that you can't stick to a particular deployment option. You need a hybrid approach because you already have the legacy system in your data center, which might need, you might need to bring in some integration component into that. So that's why we need to go with the hybrid cloud approach here. So the next step is about developer timeline and a phase approach. So practically when you try to do this kind of a project, we can't simply do it at once, right? So we need to come up with a milestone plan, and we need to divide the work in a meaningful manner, right? So that's about developing a timeline and a phase approach. And the next is implement iteratively. So here we take a step-by-step approach in implementing the integration project. So here I'm talking about how we can do this implementation for that particular project that we are talking about. Here on the left we have the legacy systems in on-premise. So we have 3 different systems. So what we are going to do is now we need to expose these as APIs. So basically we are going to create integrations as APIs. To do that, first I will create a microservice to get connected with the shipping tracking service. So in this shipping tracking service, luckily there's an external interface that we could talk using the TCP protocol. So that integration is somewhat straightforward compared to the others. So the next, we need to integrate with the inventory system. In inventory system, there's no interface. So what we could do is, we could directly integrate with the database over the ATBC. And then the third one, the order management system. There also we don't have the luxury of having an interface. So we can, but all the orders process gets stored in the file system. So we could use this file integration to get integrated with this particular system. So when you do that, we can expose all these APIs that we created as microservices through a gateway. And then all the new services that we are building for bringing the new capabilities into the system, we can do it in the iPaaS. So we just bring all the new services there and get connected with the on-premise system through the gateway, through these microservices, and offer this functionality. So that's how we incrementally build this integration project. And then after some time, so we decided that we no longer need this legacy system. We need to get rid of some of the systems. Then we can take an iterative approach for that as well. So you can see on the top there's a delivery van here. So the delivery van can send out MQTT messages to give the coordinates and the tracking information. So we bring a new service into the system and get it interconnected with our MQTT protocol. So now we have the new system, new tracking system on the cloud that get connected with the delivery vehicles. So now we can keep this two system running for some time and figure out, and we can do all the testing. And finally, we can decide to get rid of the existing tracking system. Right. So we can remove it from the gateway, and we can remove all the services. And finally, we can get rid of the legacy system as well. So that is how we do a phase approach when it comes to development. And finally, in the final step is about documenting and doing the knowledge transfer. So here of course, we need to follow best practices and document everything and do the knowledge transfer so that this won't happen in the future. Okay, so that's about what I was trying to cover. If you have any questions, you can ask. Okay, thank you.